Good morning. This is Dr. Eidelberg, and this presentation is sorting with human interaction. This is Lab 10 online using RoboDK software for simulation and offline programming. The objective of this lab is to create a RoboBar objects on Sketchup, export the object as STL, upload the STL objects to the RoboBar scene, configure the bar station, teach the robot target position, program the robot the moves, create a user interface with Python, simulate the process, create a video, and write a report. The creation of the RoboBar objects could be done easily on SketchUp. We come here to the components, type in, for example, a 3D sitting man on a chair, and we get several options. You choose one, then you export it as a 3D model. Make sure you place the object right at the center of the coordinate system, such that it will transfer nicely to RoboDK C. The next phase is to upload the objects to the RoboBar station, including all the additional objects. So what we see here is the 3D man sitting on a chair. We have here also a drinking glass. We have Sprite and we have Coke as the two options. We upload the RoboDK ABB IRB 120-3/0.6, and what we have here is a configuration where we will program the system to bring in a choice of Coke or Sprite. Once the user is making a selection, the robot is going to pick up the proper drink and pour it into the glass. When it's done, it's going to place it back and go home. Teaching the robot positions with this intended process. We have home. We have over here the approach position to the Coke. This is the gripping point to the Coke, back to the approach of the pouring point of the Coke, and then back to the place position, and similarly going from home to the approach of the Sprite, coming down to pick the Sprite, going up to the approach to the pouring point, and this will include all the points we have over here, all the target points, which will be used in software. The next phase is writing the programs. We have serving Coke as one option, and then we have moving to home, moving to the approach position, picking, gripping, coming back to the approach position, moving to the pour approach, pouring, waiting for 10 seconds, moving the Coke back to the approach position, then down. Then we detach the part, move back to the approach position and go home. And similarly, we have the same process for the Sprite. We also have a short program to replace the object in case we make mistakes. To create the human interface, we're using the Python API. It basically looks like that. This is a standard heading. The RDK is the interface between the Python program and the RoboLink, and the very few statements over here will get us going. We define choice as the result of what the message box is going to display. It's going to display Coke or Sprite. If it's Coke, if the user is pressing Coke, it will attach to the choice the letter C. If it presses Sprite, it will attach S. And then if choice equals C, the program will be serve Coke, and then we'll run the program, and if the choice is S, then the program is going to serve Sprite and run Sprite. Finally, we like to write the report, including the lab objective, scene screenshots. We want to show the movie program, the Python model, and then the simulation. We'll take a look at the reference lab, which is being used in class. We have a robot, we have an I/O interface for the user, we have a glass, we have the two bottles. Let's take a quick look at the movie. This is an in-class lab using the scoreboard. Has 5-axis and electrical actuated gripper. This is the control box with the I/O. The interface is over here, which is programmed to the I/Os, and the student here is making a choice to just clicked, and the robot is going to now pick the other bottle. Notice the approach position, opening the gripper, gripping the bottle, and then pouring. Let's take a look now at the RoboDK simulation. We click main, and we have please select your drink. If we select Coke, the robot is picking it up, pouring, waiting 10 seconds. And then if you select Sprite, the robot is pouring the Sprite and going home. Again, Coke and Sprite. This concludes our presentation, and we will continue similar other programs using RoboDK in upcoming projects. Thank you.